Hey, hello everyone. Welcome to week 6 workshop for Godot level 2. And this week, our topic will be boss design. Yes, we're going to design a boss fight in our game. All right. So, as you may have imagined, a boss is nothing too different from a normal AI agent, a normal small enemy. So we'll still have an FSM for the boss, right? Because our boss is not so complex yet. For more complex bosses, there will be more complex techniques to solve those problems. But for our case, we'll just do an FSM for the boss. And but the difference between the boss and a normal agent is that it has more ways to make decisions. And in order to do that, we will share some techniques that we can detect. We can make the boss detect the player, right? And lastly, we're gonna implement all the boss skills and also share some useful techniques when you implement a boss. Okay, so let's look at the final product of today. Right, yeah, this one will be our boss. You can see he's throwing this dynamite at our player at some position near the player, right? Oh, this asset is from the same asset box, from the same asset pack. It's just another enemy, but I enlarge it a bit, right? So because it looks like a kind of like a boss, and because it has a dynamite, I figure that maybe there's some interesting abilities that I can design. Okay, so you can see that the boss have other abilities like spawning the small goblins and dashing at the player, right? So you may have noticed that when the player is very close to the boss, then it's likely to dash at the player. But when the player is far from the boss, it will throw the dynamite, right? Okay, player is hit by the dynamite. Or I can see it can also charge at the player. Yeah, all kinds of different skills, right? And the game is fun when the player has to make decisions based on the boss's decisions to find the best strategy to fight against the boss, right? All these things you can consider in your design of the boss abilities. You may also notice that when the player is hiding behind a rock, the boss doesn't cast any abilities. It just simply navigates towards the player, like chasing towards the player a bit. Okay, so we're gonna cover all these in today's workshop. Right. Before we start coding, let's just try to think about what FSM we need to implement a boss like that. So you can see that I have drawn a simple FSM here, right? We can start from the idle state, right? Then there's a spawn state where the boss spawns all the goblins to help him. So this state transition will be based on a probability, and that probability is determined by the number of goblins in the game. So if there are a lot of goblins, we just have a lower probability of spawning them, of entering the spawn state. This is for better player experience, right? So if if you're lucky, or I can say you're unlucky, you can enter the spawn state. But if not, it will enter the chase state, where it navigates slowly towards the player, right? And then while it is chasing, there is a timer going on, right? So if within this timer, the player is near the boss and it is seen by the boss, then the boss will enter the dash state and dash towards the player, right? And if the player is far but also seen by the boss will enter the throw state to throw the dynamites at the player. But if the player is unseen throughout the chase timer, then it goes back to the idle state, right? I should draw two more arrows here from the dash to the idle and from throw to idle, right? After these two finish, they will also enter the idle state, right? And there's an idle timer as well, right? It will stay in idle state for like 2 seconds before it enters the chase state. All right. Let me just show you what I have currently implemented in the code. Right. This is the boss. You can see there are quite a few different animations. Right. This is throwing the dynamite. Right. It is normal chase, just walking, but dash is walking, but just faster. All right. The boss nodes have the usual child nodes, right? There's also a health bar. There's a spawn timer, chase timer, idle timer, right? And maybe this one I'll explain later. This is just an area for detecting the player. Right? It's quite simple. So I just created it for you, right? Nothing surprising. So this is just an area 2D. All right. So in our boss scripts, there are these constants we're gonna use in our code, right? So there's an enum of all the boss states from idle, chase, dash, throw to spawning the goblins. There are a few variables that are new to you. So there's a number that tracks the remaining dynamites and the remaining goblins to spawn. These two numbers are just for counting when it is in the spawn state or in the throw state, right? Yeah, when it enters either of these two states, there's going to be a counter and it's going to repeat its action for a few times before it stops and enters back to the idle state. All right. And okay, so it also has access to preloaded scenes for the dynamite and the goblin. Yeah, the goblin, you're familiar. The dynamite is just let me also show the dynamite scene, right? Right, it's just the dynamite itself together with the explosion area. And the dynamite also has a script that when you feed it with the initial position, the start position, and the end position, there is a script to calculate the trajectory, and it's gonna be thrown by the trajectory over a duration of time, and then it's gonna explode at the end position, right? This is not too important, and yeah. Anyways, let's go back to the boss script, right? The main focus of this workshop is implementing the boss. So, right, this is just an additional tool, additional thing that you can use together with your boss. All right. So, okay, our boss, right, these are quite standard, right? So, currently, if the boss in each of the physics process frame, it's gonna check against all the different states, right? So if it's in the chase state, there is a function called look for player, which we're gonna implement. So the logic of this function is to determine this condition is whether the player is near and seen, or whether the player is far and seen, right? Or the player is just unseen throughout the duration. So this look for player is gonna be called in every physics frame. And once the player is found, then it's gonna transition to the different states accordingly. Okay, so the chase and the dash states, we have our normal navigation. Yeah, this is nothing new. It's just a navigation script. All right, but maybe I mentioned that it should only follow target, meaning that setting the target position to be the player position in if it's not in the dash state. Why? Because in the dash state, actually the logic is that it will charge toward a position that is beyond the player a little bit, right? It shouldn't just be the player itself, right? But rather to a fixed position, which makes the game a little bit easier and more natural, right? Because of inertia, you may say. Okay. So yeah, I think there's a yeah, maybe I can point to here that when it enters the dash state, right? This is a set state function, right? When the new state is the dash state, then it's going to set the target position to the player's position plus some distance, right? So this is a target position for the dash state, and we shouldn't set the target position every frame for in the dash state. That's why there's a conditional checking here. Okay, so okay, these are These are just common functions for the character, right, and navigation. All right, so this look for player function we're gonna implement later, right? So there's gonna be is player nearby variable, is player seeing variable. We're gonna implement this mechanism to check if to detect the player, right? And the set state function. So idle state, chase state, and dash state. I have already defined all these. These are the actions. Remember that these are the actions that happen when you enter a new state. Enter all these each of these three new states. And the two states that we're going to implement today is the throw state and the spawn state. Okay, so in the idle state, there will you can see that there will be starting of this idle timer, right? And at the end of the idle timer, the boss is gonna make a choice of either chasing the player or spawning goblins, right? So yeah, there will be a timer timeout signal function that is going to enter the spawn state with a certain probability. And we're also gonna implement this later. And if it doesn't enter the spawn state, right, it will just go to the states, to go to the chase state. Okay, so throw state, spawn state functions, helper functions, or we're gonna define here later. And also there's a timeout function for the chase state that goes back to the idle state. All right, that's pretty much it for the code that I have given you so far. All right, so let's talk about the actual techniques to detect the player, right? If you think about designing a boss or designing any AI agent, right? What is your goal? What's the target of your design? Maybe one of the important target is that the AI agent is realistic, right? Its actions are realistic and natural is what is expected by a normal player. Right? So maybe you can add a ability for it to sense whether a player is nearby or not. This can be based on just the distance between the player and the boss, right? You can also think of other fun stuff like footstep, whether the player is running or not. And maybe like if the boss is a werewolf, you can define it to be the smell of the player, right? The player leaves a track of smell that the boss can follow, right? Maybe you can think of how to implement these, right? They're quite simple. Okay, and the boss can also have the ability to use their eyes to see a player, right? So maybe the player is hiding, right? Is taking cover from some block that the boss cannot see the player if he is taking cover, right? So right. So the techniques that I'm going to introduce today, the first one is very simple. It's just using an area 2D to detect the player body, to detect whether the player is within range of the boss. Right? It's quite simple, right? I think many of you have an idea of how to implement this already. All right. And another technique is using this node called raycast 2D, right? And raycast is something quite useful in Godot, in any game engine. Right? A raycast is simply just a ray of light, uh, a straight line of light, and the light stops at the first collision with any objects in its collision mask. So this is useful for this use case when you want to design the ability to see a player, right? Instead of an area 2D, as long as the player is nearby, is within the area, then it's detected as nearby, right? For this one, you have to ensure that the ray of light doesn't collide with any obstacle in between the player and the boss. Okay, so let's implement these two in our game. Right? Remember I said that there is a player detection area, right? So if we look at the inspector, I have set the collision of this player detection, the collision mask to be masking layer one, which is a player mask, right? So it's able to detect collision with the player and nothing else. Right, so very simple. We're just gonna do onReady, just assign a variable to it, player underscore detection equals, drag this node here, right? And let's scroll down to the look for player, this function that we're gonna implement using the techniques. So this variable is player nearby. We'll be just checking if the player body is inside the area 2D or not. For this one, Godot has a function for the area 2D, right? So if we player underscore detection dot get overlapping, you can choose overlapping areas or overlapping bodies. So these are just if it gets the area 2D or the actual physics character body that is overlapping with this area. So we can just get overlapping bodies, right? And then player in. If the player node is in the list of overlapping bodies with this player detection area, then we can see that the player is nearby. All right. If I haven't mentioned, this big circle, this big capsule collision shape is for this player detection area. Let's just check this out. I've also print the function to print the nearby and the scene, right? So if the player is nearby, then it's going to change to true. All right. If the player is not nearby, then it's gonna be false when the boss is looking for the player. All right. So that one is simple. It's just an area 2D. And now we're gonna implement the raycast 2D, right? So let's go to the boss node and then add a child node. Search for raycast 2D. All right, maybe drag it to arrange it a bit to be under this player detection. Okay, so let's look at this area, this raycast 2D. Actually, it should show here. Let me just change the change the scale a bit. Maybe we can change the X scale to be 1000, right? Then you can see this uh blue rectangle, which is just the collision shape for this raycast 2D. All right, right. So you can also scale in Y direction, right? Wait. Okay, you can see that actually this is pointing downwards. It's kind of like an arrow shape, right? But let me just wait. I'm not too sure why it looks like that. Anyways, let me rotate it a little bit. Right, that's a little bit weird. Anyways, let me try. Oh, okay. I see why. Okay, never mind, never mind. Sorry. So, right, it's not a good idea to scale the raycast 2D, right? Actually, the way to define its collision is in this target position. So, you can see right now the target position is 0x, but some y value. It's pointing to the right because I set this rotation. Let me just change this back. So you can see here that this is the target position of the raycast 2D, right? And if we change the y position to 1000, then it's gonna be like this. If you zoom in really hard, you can see the slight arrow shape raycast 2D, right? And the way we're gonna implement looking at the player, right? Maybe you can take a moment to think about how would you use this ray of light to mimic looking at the player. All right. So the answer is quite simple. We're just gonna set the rotation of this raycast 2D, right? This rotation transform, right? So that it is pointing towards the player, right? That's pretty much about it. If the player is here, we can set the rotation to be an angle that so that this points at the player. All right. And in order to do that, maybe I can set this back to 0, and we can change the target position to be on the positive x-axis so that the angle you calculated will just be the angle to rotate to get to the player. Right, hope that makes sense. So we're going to set the target position of x to be 1000 pixels and y to be 0. All right, so initially, this raycast is pointing to the right. All right, set the rotation to 0. Right, and we'll change the rotation later in the game. Okay, so right, there are quite a few options for raycast as well. I believe they are quite self-explanatory. For example, this exclude parent just means whether this raycast should exclude this boss parent or not, right? Because we don't want it to collide with the boss, then we just toggle on this exclude parent. All right. And by the way, if you may be thinking that if I set the scale of this raycast, then it's gonna alter the collision shape to be fatter, right? If we change the y to be 100, then it's gonna be a very, very thick ray of light. But actually, that's actually not true, right? So no matter how you scale it, it's still gonna be very thin, a very you can think of it as just a line or a thread of light, right? It's not gonna be thicker. Okay, this is mainly just for debugging purposes to make you see this arrow more clearly. Then you can scale the y. Okay, so back in our program. Right now we're gonna try to calculate the angle and also determine whether the player is seeing or not. So, all right. So how do we calculate the angle? Turns out in Godot, there is a function that is quite useful, right? For any vector 2D, you can just calculate its angle from the x-axis. So if we do global position dot direction to the player's global position, right? And then after getting this vector, then we angle. This will just be the angle in degrees. Is it radians or degrees? Right, this one is in radians. I believe there is an angle in degree function, right, that you can use as well if you need it. Right, so we can just set the rotation of this raycast 2D. Right, but before that, let me just add this variable to access this raycast 2D. So onReady variable ray underscore cast equals this raycast 2D node. Okay, and that completes this to do. All right, so we can set raycast dot rotation. This rotation is also calculated in radians, right? So they match, equals to this angle. All right, so whether the player is seeing or not, we can just set this to be whether the collider of this raycast is equal to the player. So we can just call this get collider function, right? This will return the first collider with the raycast. Then whether this is equal to player. Okay, right. And there's one more thing to do, right? Don't forget to set the collision mask of this raycast. Currently, it only masks the player, so that is not really useful. But what we want is to make it being able to be blocked by the rock, right? So this should be masked with both the player and the rock is on layer 3. So we just set the collision mask to 1 and 3. All right, so let's see this in our game. Maybe I can turn on the visible collision shapes in the debug. Then you can see that, right? So there we can see the collision shape of this detection area and also the raycast. Okay, let me just zoom out a bit. And this area, this collision, this raycast being red means that there is a collision with the raycast. Right, so now you can see that if the player is exposed in sunlight, then it's gonna be player scene is true. But when the player hides behind the rock, then the first collider with the raycast is the rock instead of the player. So this is gonna be false. All right. Okay. Right. So raycast is a very useful tool to implement something that only collide with others once. Okay. So now we'll move on to implementing the actual skills of the boss, right? So I would say that the implementation really depends on how you design the skills, right? If you design a very complicated skill, then it's gonna be a harder task for you to implement, right? But it's also a something that it looks better and makes you feel more satisfied, more excited. Don't know, right? So for this boss, right, the skills that I choose is spawning the goblins, dashing towards the player, and also throwing the dynamite. Right, I feel the throwing dynamite skill is quite cool, right? Right, with all the trajectory of the explosion, right, and all the player has to really look out for those target positions of the dynamites to while the player is attacking the boss, attacking the goblins, he also has to avoid those dynamites, which is quite a fun experience, right? Of course, you can think of other interesting skills to add to the boss, right? It's only a matter of how you implement, how you design it, and then you think about how to implement the actual skill. There's no fixed way, right? But I'll just introduce a few common patterns or common solutions to some of the skills, right? So the first trick will be making good use of the signals of all the signal function calling and recursive timers, right? Recursive timer is useful when you want to repeat a skill for a number of times, right? So remember that there is a remaining number of dynamite and remaining number of goblins variable. So this is just gonna be a timer that when it times up, it checks the number of remaining objects to add to the game, right? And then if it's larger than 0, then it's just gonna decrease it by 1 and then start a timer again. And on the timeout, it's gonna check and decrease again, check and decrease until it finally reaches 0. So this will achieve counting. This will achieve a counter that controls how many dynamites or goblins that we add to the game. All right. And another trick is this animation player, right? If you look at the boss scene, this animation troll player, right? And there's a Right? This is just an animation, right? And there are two tracks here. The first track is the frame of this animated sprite. All right, and then it's just gonna switch the different frames. Okay, so instead of playing the animation in the animated sprite, we're gonna play the animation in this animation player, which also works, right? If you think about it, it's just gonna change to the next frame at these key points, right? This is equivalent to playing the animation. The actual really useful track here is this. This is called a method, a function method or method call track, right? You can call a function at a certain point of this animation, right? So this is very useful when you want to call a function at certain time of the animation, right? In the middle of this animation, around this time, around frame 5, you want to throw the dynamite, right? So without this, what you would do is you have a separate timer that runs concurrently with, I don't know, the animation, right? So there's a timer that starts whenever the animation starts, right? And then when the timer has a wait time of this long, this much, and then when the timer times out, it calls its function, right? So this is just not elegant. And this elegant solution is using this function call track, right? And at the 5th frame, let's look at the sprite of the throw. So at this fifth frame, right? You want to make sure that at the time of this frame, right, corresponding with this key point, right, you're gonna call the throw dynamite function, which can make our code quite clean. Okay, so this is another useful trick here, right? So now we are gonna implement the boss using these tricks. Okay, let's go to the boss script and let's look at the first function, the first to do here, right? We already implemented the mechanism to check whether the player is nearby or seen by the boss, right? This one is done. And next, we want to follow the FSM, right? So if the player is nearby and also seen, then we change to the dash state. If it's nearby but not seen, we go to the throw state. Otherwise, we do nothing. Right? Just keep chasing and look for player. So we're just gonna do if is player nearby and is player seen. Then state equals boss state dot dash. And elif, this is not fulfilled, but the player is seen. That means it's not nearby, it's far away, but seen. So elif player is player seen. Is player seen? Then we change the state to the throw state. Okay. Right, we can remove these two print statements. All right, so that completes this look for player function, right, which captures the logic of transition from the chase state to these two states. Okay, now we are gonna implement the actual skills of the boss. So let's do the throw state first. So this will be under the boss state.throw. So let's define the actions when you enter the throw state, right? So what actions are you gonna implement when you first goes into the throw state, right? Just take a moment to think about it. All right. So the actions that you want, right? Remember that we have this track, right? So it's just you want to switch to the throw sprite, right? In the animation sprite, want to switch to use the frames of the throw animation. And then you pause there, right? You don't play the animation because we're gonna play the animation in this animation player. If you play both, there's gonna be a bug that is gonna repeat twice, right? If you can try it later. Just take note that if you want to use this method, you just throw to the correct sprite frame and then pause the animated sprite, and then you just play the throw animation. Okay, and the logic that the counter logic for the dynamites is not being implemented using a timer here, right? Because we have an animation, and when the animation finishes, we can add a signal function to implement the counting and whether to switch back to idle state or not. Okay, so let's do this. When the boss enters the throw state, let's change the remaining number of dynamites to be any number you like, which is the number of times that the boss throws the dynamite. We can add some more fun, more variance to the game by setting this to be a random value. Let's just do random int range of from 2 to 4. Right? So next we switch to the throw sprite. So sprite dot play throw. Immediately after that, we want to pause the sprite because we don't want to play the sprite from this, don't want to play the animation from this sprite. Dot pause. All right. And then we can access this throwing animation throw, and let this play. Right? It's gonna play this animation, both of these tracks. Okay. And then the counter logic, let's go down to the throw state, these helper functions here. Okay, so maybe before the counter logic, let's just define a helper function that throws a dynamite towards the player position. All right, so for this one, let's define a function called throw dynamite. So as you know that we want to introduce a new child to the game, right? To add this dynamite as a child to the game. So remember that we have the preloaded scene here. So what we're gonna do here is a variable dynamite just equals to dynamite.instantiate. I'll instantiate a new instance of the dynamite. And then later we're gonna add this to the game. So later we just get parent dot add child this dynamite. But before we add the child, another thing to do is setting the positions, the initial position and the target position for the dynamite, right? So it's just how I implemented this dynamite, right? You have to give it a start position and the end position. So the starting position, we just set it to be equal to the position of the boss. So dynamite dot start position equals the global position of the boss. And then the end position can just be the player's global position. Or end position equals player's global position. Right, and then we add it to the game. Okay, so actually in my script, there is a random perturbation to the end position. It's just to add some randomness, right? You don't want to aim at the player directly. You want to aim at an area that is next to the player so that it kind of predicts where the player is running, right? So this adds more fun to the game, basically. But that's handled in this dynamite script, and we don't have to care about this here. Okay, so that's our throw dynamite function. And then for the counting mechanism, we'll just use the signal of animation finished for this particular animation player. So go to this animation throw and go to this signal, right? Node signals, and can disconnect this first. So use this signal called animation finished, right? This one, we also introduced this signal in our last workshop, right? This is for states that should only last the duration of this animation. But for this one, we're gonna utilize this signal to see if the current round of animation has finished. Right? If it's finished, we can call the function. We can call this signal function, right? And then implement the counter. If the counter is still larger than zero, then we play the animation again. So, okay, let's move this one up first. Here. Right? So when this animation finished, we can set the remaining dynamites to be -1, minus equals 1. Right? And then we can check whether there is still remaining dynamites or not. So if the remaining dynamites number is still larger than 0, then that means we should play the animation again. And in the next round of animation, there's gonna be another call to the throw dynamite function, right? Here in the method track. And then it's just gonna throw another dynamite, and it keeps going on, right? So this if it's larger than 0, then we can just play the animation throw again. Play this throw dynamite animation. Okay. And else we switch back to the idle state. So state equals boss state idle. Okay, I hope this logic of counting is clear to you, right? Using this signal. Right. While I was coding here, I realized I forgot to add this string name of this animation somewhere here in the throw state. Okay. So let's add this animation throw dot play of the throw dynamite animation. All right. And that completes the entire throw state, the entire throwing dynamite skill, right? It's not too complicated, right? I mean, it's just instantiating a new child and then implementing accounting using this animation player signal. All right, but the main takeaway is using this method track, right? It's really useful, right? It's also useful when you want to enable and disable the collision shapes of an attack. Right? Remember that in our first workshop, the way we did this is enabling the collision shape at the start of entering the state of the attacking state, right? And then disabling it at the end when we exit from the attacking state. But sometimes you don't want the entire state duration to have that collision shape. And that's when you can use this method, right? You can set it's not the it's not the method track per se. It's another track called property track. You can just set the property of the collision shape to be either enabled or disabled at some of the key points. Okay, so that's the throwing skill. And now let's move on to our final skill, which is the spawning goblins. Okay, so let's first deal with the action of entering the spawn state based on the probability, right? So that will be in the idle state timer. Let's see, where is it? Right, on idle timer timeout, there's a function call to this entering spawn state with a certain probability. All right, let's do it here. So let's define a new variable called probability, right? So now we need a way to check the number of goblins in our game. There are so many ways to implement this. Maybe you can also take a moment to think about how you implement checking the number, the count of goblins. Okay, so the way I choose to implement it is to have a shared variable in the game node, in the level 1 node actually. If you go to this level 1 script, there is a variable called goblin count, right? And then there's a function that you can update, you can increment this goblin count. And in the goblin script, in the die function, before queuing free is going to update the goblin count to be -1, to decrease by 1. So here, in the boss script, we can get this get the count of goblins in the level 1 node, which is the direct parent. So we can just here a variable goblin count equals to get parent dot goblin count. And then we can set its probability based on this goblin count. You can set it whenever to whatever value you like. And I'll just give an example here. So let's say if goblin count is smaller than 3, that means a very few number of companions of the boss, right? We can set the probability to be a high value, let's say 30%, right? We can make it 30. We can put 30 here. Later we're gonna choose from 0 to 99. Okay. So if goblin count is less than 6, then the probability is, let's say, 15. And if goblin count is less than 9, this probability can be maybe 5 or 10. And else there are too many goblins, and we can set the probability to be 0. Well, you can see that here I choose the probability based on this discrete range of goblin count. You can also implement something like a math function, right? Just either linear or maybe exponentially decrease of the probability. Remember to clip it to the range of 0 to 100, right? Anything you like. And after that, we're just gonna enter the spawn state with a random number that checks with this probability. And if it's smaller than this probability, then that means we get our lucky draw and we're gonna enter the spawn state. So we're just gonna do if ran I range, actually just ran I and mod ran I mod 100. So this will choose a random integer from 0 to 99, right? Is smaller than this probability. Then we enter the spawn state, set the state to boss state dot spawn. All right. Okay, I think that's it for this this function. It checks if the state has been overwritten to spawn state, right? If yes, then it just returns. If not, then it's going to enter the chase state. Okay, and the last bit to do is helper functions in this spawn state. Right, so let's first define a function to spawn one goblin at some random map position, right? So this map position, I have defined two constants here, right? Either the min position or the max position, right? By min and max, I just mean the top left corner and the bottom right corner, right? So this value is not the mathematical min or max value, but just to take note. Okay, so for the for the helper functions in the spawn state, first, let's define a spawn goblin function. Function spawn goblin, right? We can just define a variable of the new goblin to be a new instance of the preloaded goblin scene. So it's a goblin dot instantiate. Right? Then we can set the initial global position of this goblin to be a random value within the range of the map position constants that we have set. So goblin dot global position dot x to be a random float of the range from the min positions x to the max positions x. Right? Then we can do goblin dot global position dot y to be similarly, there's an error here. Oh, there's no error. To be a random float, right? So this will be, let's see, it should actually range from 200 to 1200. I don't know why I set it like this. Well, it should be 200 and 120 here. Okay, never mind. Just update the values here, right? So the min is 200, 200. Max is this one, right? So it should get a range from the min positions y dot y to be the max positions y. Okay, and now we can safely add this goblin to the game. So get parent. Let's add the child of this goblin. And don't forget to update the goblin count in the parent. Similarly, call the update goblin count function with the delta value being 1. All right, so this is the spawn goblin function, right? And now we want to have a mechanism to spawn it, to call this function for a certain number of times, right? And remember, we have a technique here, which is the recursive timer. So we have this spawn timer that at the end of the spawn timer, we can call the spawn goblin function. And also update the count and check if we want to spawn again. So let's go to the boss scenes spawn timer here, right? Disconnect this one first, and then just add the timeout function to our code. Let's move it here, right? There is something wrong here. Huh? Oh, wait. There's a slight indentation error, but never mind. So when the spawn timer times out, right, what we're gonna do here is just to call the spawn goblin function first. And then after spawning the goblin, we're gonna decrease the number of remaining goblins to spawn by 1. And similarly, just check if the number of remaining goblins is larger than 0 or not. If it is, then we just restart the spawn timer, right? So you can see that it is a recursive timer. So spawn timer dot start. Okay. And else, if we have 0 goblins left to spawn, we set the state to be back to idle state. All right. Right. So this is the recursive timer. And there's one more thing we need to do is the actions that happens when we enter the spawn state, right? So we should set the number of remaining number of goblins and also start the first timer. So let's just do here remaining goblins to spawn. Maybe also add some random value here. So random integer of range, I'll say from 3 to 5, but it can be any value you like. And then we start the timer for the first time, which spins off to this cycle of recursive calling and ends when the dot start. And it ends when there's no more goblins to spawn. All right, let's check if there's any more to use. Okay, we have completed our boss. Let's start the game and see how it goes. Okay, you can see that if the player is far away and is being seen by the boss, then it's gonna throw the dynamite. If it's close to the boss, then the boss is gonna charge at the player. Wait, you are not set the relationship with the boss. Wait a minute. Let me just turn off debug first. See if we can attack the boss. Okay, there's something wrong with the boss's collision layer, right? This is the take damage function. Oh wait, I think I deleted this wrongly, right? Oh, it should be fine on your side, by the way. I think I accidentally deleted this hurt animation before the start of this workshop. Right. So let me just add this back in. Let's remove this throw dynamite animation from this. Oh wait. I see the problem now, right? So because the way I created this is by duplicating from the throw, right? Then I added the hurt. And by duplicating, they're actually pointing to the same object. So when I delete the animation, it deletes for both. Okay, this has been a very old bug for not say bug, but I'll say feature for Godot. Right? It's kind of annoying, but just to make a mental note that whenever you duplicate, there could be some changes that will be applied to both duplicates. Okay. So let me just add back the hurt animation. And this will be a property track of the sprites modulation that lasts for 0.4 seconds. And there will be 4 key points, 2 or 3 key points, right? And in the middle, then we set the value to be the red value. Okay, let's see. Okay, so it's working now. Okay. Okay. Let's also test whether the spawning is working, right? So there's a probability depending on the number of goblins that is gonna spawn from random positions. And by the way, if you're worried that it might be spawn in these obstacles, right? I tested this out, and if in the case that I can see it is actually spawned in the middle of this rock, then it's just gonna start avoiding immediately, and then it's able to move away from the rock. That's because we never set the collision shape, the collision between the goblin and the rock. That's why it's not going to be buggy. All right, so we have a cool boss over here, right? And now if you're hiding from the boss, it's not going to be able to cast any skills, and then it's just gonna navigate to you unless you are not being blocked by a rock. Okay, right? So yeah, the values are quite balanced, right? I set the values to be quite balanced. You can take the challenge to try to defeat the boss I designed, right? It's a little bit difficult, but it's doable after a few tries. And also if you want to implement your own boss, like you think my skills are not cool enough, right? You can for sure you can try to think of new things to add to this game and make your boss better. All right. So that's all I want to talk about for the techniques in boss designs. Maybe some other useful tricks that I can think on top of my head, right? So first one is adding stages to your boss fight. Right? You know, in some games, when the health of the boss falls below half, then it enters stage two, and so on. So maybe you want to have an enum for the stages, right? Stage one, stage two, similar to the states to make it more visible, make your code cleaner, right? And you can have a constant multiplayer if you want to use that for different stages. Let's say for stage two, you want to multiply all damages by 1.5, right? Then you can have a few multiplayer constants. Let's say the constant for stage one is 1, the multiplayer for stage two is 1.5. Then you just times this multiplayer to every damage variable in your game. Like when you want to deal a damage, right, just multiply by this multiplier. All right, the second I wouldn't say trick, it's just an advice is that you want to keep all those magic numbers, meaning the raw values, the raw integer values, the all of these are numbers themselves as variables instead of all the different numbers, right? This is because when you do a boss fight, there's gonna be a lot of balancing that will happen after you code. So like for each of the skill, right, for each of the stages, there's gonna be there's gonna be many balancing efforts, and the balance is gonna be much easier if you just modify these constants at the start of your code instead of trying to find all the magic numbers inside your code. Right? The third trick, as we have already written in our code, right, there is a lot of random numbers. So maybe you want to add some more randomness to the boss fight. The number of goblins that it spawns, the number of dynamites that it throws, and also the probability of entering each state. Let's say maybe you are close to the boss and it doesn't dash at you directly, but instead it has a probability of doing so, right? So this will make the game less monotonous and increase play experience. Right? And if you are working on a bigger game project that has a bigger boss, a boss with very detailed actions, maybe you want to look at this thing called behavior tree. This is an alternative to FSM, and it defines the detailed behavior, the decision-making behavior of any AI agent. Very, I would say, it's useful when it's very detailed, right? It has an entire big tree of different behaviors and how it moves from one behavior to another behavior based on some conditions. You can check this out if you're interested and if you are working for a bigger game project. But for smaller ones, I would still suggest using FSMs. I believe for Godot, there is no built-in support, but there are some open source libraries that implements this behavior tree inside Godot, and you can check it out. Okay, so with that being said, this will be the end of this workshop, as well as our series of workshops for game AI. All right, I hope you had fun learning how to make these little AI agents in your game and make your game more fun for the player. And next week will be recess week. And the week after that, week 7 is going to be exam week, right? So we are going to skip workshops for 2 weeks and come back in week 8 when we'll be talking about object-oriented programming and some SWE principles in our game, right? This should be handled by another workshop head, right? Not by me because I have a busy schedule, right? But right. What I want to say, right. If you're interested, please stay tuned, right? Maybe we'll have some polls in the Discord later. If you want to come to the physical venue, then please answer the poll, right? Because our attendance rate is not very good. We really appreciate if you can come physically, and it's gonna be more fun and more productive when you come physically as well, right? And also, right, I think that's it. That's all I want to talk about. Okay, so thank you for watching this video, and yeah, have a good break and all the best for exams. Bye bye.